Alright, hey everyone, my name is Logan Johnson. I am the reporter for Group 2, and we did the bomb calorie meter experiment last week. So a little bit about background of the experiment. The PAR oxygen bomb calorie meter measures the amount of heat released on combustion of various fuel samples. So in this experiment, we used benzoic acid and a Skittles gummy. The heat of combustion, so the Q for the benzoic acid is already known, and we're going to use that to find the thermal capacitance of the calorie meter. And then, you just use the first law of thermodynamics and basically rearrange it 2 or 3 times to get all your values. And then once you have the thermal capacitance of the calorie meter, you can use that to find the heat of combustion for the unknown fuel sample, or the gummy. So here's the apparatus. At the top, you can see 6 and 7, 6 being the thermocouple, which is connected to your computer, which is giving the temperature reading, and then 7 is the stir. And then the bomb itself is submerged in a bucket of water, and the thermocouple will be measuring the temperature of this water. And then on the right side, we have the bomb itself. 1A and 1B are both valves, one being the relief valve and one being the inlet check valve. You have your electrode terminals at 1C, which are connected to the crucible, which is hanging inside the bomb, and the fuel will be placed, inside the crucible and then ignited. So laboratory safety, standard PPE, obviously, wear pants, goggles. You're also handling a chemical, benzoic acid, so just be careful not to get that on yourself, in your eyes, or anything like that. And then the bomb itself is pressurized to 30 psi, so just be careful when handling that as well. So the objective of this experiment is to calculate the thermal capacitance of the calorie meter, and then calculate the heat of combustion for the unknown fuel sample, and then compare that to the heat of combustion for the known fuel sample, and then to just kind of understand how the oxygen bomb works in the calorie meter. So some issues we ran into about every issue you can. When we got there, the computer wouldn't turn on because someone stole the charger, so it took us about 15 minutes just to get that working. I will talk about this later, but I'm pretty sure our connection with the thermocouple was off, because after the first trial, the water was hot, but we did not get a single reading for the first trial, so that was kind of an issue. We also didn't turn on the stir for the first trial, which the stir is meant to just kind of facilitate the convection of the water and try to get a uniform distribution of the heat or the thermal energy. And then our bomb did get turned over at one point, I think, so I don't know how that would have affected the fuel, but yeah. Okay, so this is a previous group's trial, because we did not get any data for the first one. But you have a max delta T of about 2.4 degrees Celsius. And it does take about 2 minutes once the bomb is ignited for any noticeable temperature change to take place. Okay, and then this is our experiment with the Skittles gummy. We had a max temperature difference of about 3.2 degrees Celsius. And it also, again, it took about 2 minutes before any real change was noticed. Okay, so here I noticed some pretty stark differences in our unknown fuel sample versus theirs. So ours was a Skittles gummy, theirs was a Mike and Ike. You can see on the right, on their side, theirs started at about 24 degrees Celsius, and it ended not even at 26, while we started at 30 degrees Celsius, which is obviously significantly higher. I think if we were to do the experiment again, we should have waited longer for some of the heat to dissipate out of the calorie meter. That was probably an error we made there. And then with the Mike and Ike, they calculated their Q to be about 26, and ours was only about 11, but our Skittles gummy was significantly bigger than the Mike and Ike. So using the Q, like I said, from the benzoic acid, you can calculate the thermal capacitance of the calorie meter to be around 96 kilojoules per Kelvin, which is about what we thought it was going to be. And then the total Q from the benzoic acid was about 26 megajoules per kilogram, and then ours was significantly lower at 11 megajoules per kilogram. Again, I think this is partly just because we used a lot bigger of a fuel sample, so you're dividing by a bigger value, and then also the water was a lot hotter when we started it, so maybe the delta T would have been bigger than 3 if we had waited for some of that thermal energy to dissipate. And then sources error, like I said, just kind of the equipment was off. I think the water was hot, so I think the thermocouple was the issue there. Wait for the water to cool down a little bit after you do it, because ours was pretty hot compared to previous groups. And then just the resolution of the equipment, measuring the gummy and whatnot. And those are my references, and that's it. Does anyone have any questions?
So just a comment, right? Yeah. Nice. This actually what the experience is about. But the starting temperature doesn't really matter. So you could start like.
I was kind of wondering because like the specific heat of water, I guess, is constant at constant pressure, so I wasn't sure.
Yeah. So what really matters is the temperature difference.
Do what?
Temperature difference.
Mm-hmm.
So you could start at 20 degrees Celsius,
and then it would still take the same amount of energy.
Yeah.
Okay.
So yeah, and then I think the value of the heating value for benzoic acid corresponds to the standard value, which is 26 megajoules.
Right.
So which is correct. Yeah.
Oh yeah, that's a given.
Exactly.
That's not calculated.
Oh, okay, just give it. Okay.
I think it is a given.
Right.
Yeah, and then you use that to find it.
Yeah. So and yeah, I think it's fine. Yeah.